9:35. Let's go ahead and get started. I'll share my screen before I forget. Start the recording and open up VS Code. Yes, morning, everybody. In the back, there is a handout on material for the quiz that will happen not next class period, but the following week. We'll be going over that today a little bit. So make sure that you have a copy of that. Before we go over that material, though, I have a number of announcements, things for us to just talk about. And again, at any point in the class, if ever I have something on the screen that is too small or you can't see it for whatever reason, just shout it out and I'll make it, try to make things bigger. Might be a little too big. But so yeah, quick announcements. So again, the lab due last night, but if you haven't submitted it yet, that's totally okay. You have until Tuesday night if you collaborate with people in any way. And again, that means going to the QCL, talking to, working with other people in this class, working with a friend at MUD or Pomona or somewhere else, somebody else who's previously taken this course, anybody who is going to be helping you on this assignment, helping you learn, that's okay. And again, the point of this collaboration is so that you get whatever you need to help you learn the material. I want you to have access to that. If for whatever reason you feel or felt overwhelmed by this first lab, that's 100% okay, totally normal. And so I have a couple of comments about that. The first one is that one of my goals with this lab and all the previous ones, kind of throwing so much stuff at you at once and maybe intentionally overwhelming you a little bit, is to get you all comfortable with this feeling of like not knowing what you're doing, being comfortable with feeling totally overwhelmed. And I'm going to switch my screen real quick over to GitHub. I'm on the current week 3, topic 3 folder, Python containers, and I just want to show you this meme right here. This is the 2 states of every programmer, not the 2 states of beginner programmers, but the 2 states of every programmer. So me included, I've been programming at this point for about 20 years, but alternating between I have absolutely no idea what I'm doing, like a dog at the computer, and being a god. And so if you feel like you have no idea what you're doing, and like your dog is smarter than you at programming, then you are in the correct state of mind for being a professional programmer. The people at Google constantly feel this way. And so part of the purpose of this confusion is intentional, like overwhelming you with things, is to get you comfortable with that feeling, because it's not going to go away. It's there forever. And another sort of metaphor that I like to use about learning Python is that Python, you can think of it like a foreign language. Like if you're a native English speaker and you're learning Spanish, then there's a number of possible ways to learn Spanish, but one common failure mode of people learning foreign languages is that you just go to classes and the teacher presents these nice little package things and you understand everything, but then you go to Mexico and you have no idea what anybody's saying because you've never actually like been immersed in the language. You've never actually struggled with the things. And so somebody who's just like moved to Mexico, moved to your foreign country where they're talking the language, you're gonna be totally overwhelmed at first, and you're gonna be totally overwhelmed for like the next 5 years of your life, but you're gonna learn a whole lot more and actually be able to interact with things. So this is like a learning by immersion in Python. I'm actually throwing you right into Python, giving you all the tools that people at Google, Facebook, all these companies are using. You're using them right away. And it is overwhelming, but you will be learning a lot, and you will be, at the end of this course, at the end of really the next couple weeks, you'll be very, very good at all of these tasks, all this programming stuff. So again, takeaway is that if you're feeling overwhelmed right now, that's normal, okay. If you are feeling overwhelmed though, a great way to help you be less overwhelmed is that all those pre-lecture videos, textbook things I've been posting on GitHub, doing those before class, because really the purpose of class in here is not to give you the first introductory presentation of all these concepts, but to tell you or to help you prepare for the labs and the quizzes, making sure that you're integrating that knowledge, the basic knowledge with what's expected for this class. So I mentioned before that the very first day of class, that there are some students who historically have needed to spend about like up to 20 hours per week on this course. And that's especially true for this time period right here, where we're first getting into Python stuff. If, like the next 2 to 3 weeks, most important part of this class, because all the material that we'll be covering is stuff that you will have to know like a month or 2 months from now. And so at some point, you're going to have to put in the work to learn that material. You may as well do it now and get the good grades, good understanding of the assignments now, rather than trying to put it off till later and not getting the good grades. Again, the QCL, especially at this point in the class with the basic Python understanding, there'll be lots and lots of people in the QCL who can help you with this. So go to the QCL, make like little huddles of people from CS40 people, and the QCL is, again, something that everybody has access to. You don't have to be a CMC student. If you're wherever other school you're from, you can use the QCL just right across the hallway over there. Next class period, we'll have our next quiz. The format of the quiz is the problems that I gave you that we went over last week. I'll be just selecting 5 of those problems. There's 42 that I gave you in that packet, so there's a lot of practice for you to work on. I'll be selecting 5 of those problems and just minorly change around the problem with just like different numbers, so you have to rework through it. But the format of the problems is all going to be exactly the same. It's testing your basic if statement, for loop, function definition, and how all those things get applied. And again, I will be here at least 10 minutes early before the start of class that you can come take the quiz. I'll try to be here about 20 minutes early. And so you'll have sort of the additional time. If you still feel like that's not enough, let me know, and we can arrange a time for you to take the quiz with unlimited time outside of class. The point of these quizzes is not to test you like how quickly you can do things, but your understanding of things. So I don't want anybody to be under time pressure for these quizzes. Last sort of note, if you do have questions after class hours, then happy to try to help you. Again, GitHub issues, the main best way to get those questions resolved, posting those issues to GitHub. That means up at the top over here of our class repository, pressing issues. You can see there's been lots of questions posted so far. So I've been happy about how people have been using that. Handful of people have emailed me with questions, and I've redirected you to GitHub issues to repost the question here. Again, GitHub issues should be the primary source for questions about anything content related in the class for a number of reasons. One is that way everybody will have access to the question and the answer. Another reason is that maybe somebody in the class can answer the question faster than I would be able to get to it. But a third, even more important reason potentially is, again, GitHub is a platform used by all these tech companies as they're doing recruiting. They're going to look at your profile. All the applications for a job at any tech company has a spot where you can put in a link to your GitHub profile. And one of the things that they do is they just look at statistics about how much you use GitHub, how many issues you've posted, how many different projects you've done. And so by doing all of this stuff through GitHub in the class, we're giving you a head start on building that portfolio for your future job applications. Also helping you get comfortable with, like, if after class, like a year from now, you're coming up, there's some programming tasks that you want to do, and you're having questions with it. This is the standard way that people ask questions about whatever. They do it on GitHub in an appropriate repository where people are working on that same task. You post your issue asking a question, and then somebody from around the world will help you out if you ask it in the right way. And this is getting you practice asking those things in the right way. Okay, I'm out of breath. That was a lot of announcements. Any questions about anything administrative in the course? Everybody had a good weekend? Couple head nods. Anybody have midterms yet? The other class that I'm teaching has a midterm this week, so y'all can be grateful you're not in that class. Again, no midterms in this class, no final. It's all going to be projects and then these weekly quizzes, making sure that you don't fall behind. Okay, so today our material is getting into lists and dictionaries, these things called containers in Python. And coming back over to our this topic 3 folder. This is chapter 4 and chapter 5 in the textbook, and there's a whole bunch of videos that go over all of these things in detail. Again, highly recommend you watch them. In class, we're going to go over more how this applies to the quizzes and the lab for this week. So, coming back over here, I'm going to open up the interactive version of Python. So in order to get, you notice right now, I have only this text window open. I don't have that terminal thing down here on the bottom. In order to get that terminal thing opened up, I'm going to just have any old Python file opened up, anything that ends in .py. So here I just randomly happen to have the lab.py from last week, but it doesn't matter. Anything with this triangle button on it, I can press that triangle button and it'll open this terminal window for me down here. In order to get into the interactive Python mode, I have to first identify what is my prompt, and then in one of these previous lines, find that prompt and then find the big string that ends somehow in Python 3. And again, this is going to be different for everybody's computer. I'm going to copy and paste that string by itself down here. So it's just the big long string that ends in Python 3 and hit enter. When I do that, my prompt changes. The thing to the very left over here changes. Before it was, for me, it was ended in a $sign. Yours might end in something different. But once you enter the interactive Python mode, you're guaranteed that it's going to be these 3 greater than signs. So you know, if you ever see these 3 greater than signs, you know you're in Python. And if you type in Python code like 1 + 2, it's going to do those computations for you. Again, you can exit interactive Python by typing exit. Now you're back to a normal terminal. And if you press the up arrow, it goes back to whatever previous command is that you've had up here. Here's my, for my computer, what the interactive Python looks like. Hit enter, back to the interactive Python down here. And we're going to use interactive Python here just to explore a little bit about lists and dictionaries. And then we're going to switch over to Python Tutor to look at some of the quiz preparation questions for next week's quiz. Before I get started, though, here we go. Again, make sure, or I highly recommend you have your Python cheat sheet out in front of you so that as I say, oh, this thing right here that we're talking about is super important, something that you absolutely have to know, you can make a little note on your cheat sheet about highlighting that thing. Also, every programmer, professional programmers have certain things that we have cheat sheets for, and we always have those out in front of us while we're working. This is not something that is like only for beginners. This is, everybody uses cheat sheets because everybody feels totally lost at times when we're programming. One of the things, again, with programmers, hackers, this hacker culture is that we abhor like make work, fake stuff. And one of those things that we abhor is like needless memorization. Why should my brain do all this work memorizing stuff when paper is perfectly good at memorizing and can have all of this stuff for us in front of us? And so there's no need in this class to memorize all of these different things. You have this cheat sheet out in front of you. You're always able to reference it for quizzes, for labs, for projects. So have it out when we're going over things in class. Last week, we covered a number of these boxes. We talked a little bit about these math operations, about this Boolean logic, these conditional statements over here, these iterative loop statements and conditional loop statements. So it's the while loop and the for loop. And then these integer sequences down here with the range. Today, we're going to be focusing on this generic operations on containers, this like yellowish thing on my screen, this black one down here. And it's a little bit annoying. You'll have to flip the page over, but it's this blue sequence containers indexing. And this is going to be the most important one to at the end of lecture today to make sure that you know what's going on in this particular box. Any questions about our setup before we get started? Yes, Henry.
I'm thinking it says instead of like the normal like command, it says $3.2 sign.
So the question is about in the terminal down here, something weird's showing up.
Yeah.
That's going to I'll have to take a look at that after class. Yeah, we'll be in the terminal here for about 5 or 10 minutes, and then we'll switch over to Python Tutor. This will just help us get a familiarity with the syntax stuff in a little bit faster way. Yeah, but good question. Okay, so in Python, lists are containers. They're things that store other things, and square brackets are the sort of the notation that we know is a list is coming. So like 1, 2, 3, like this is a list. And if you type in a list in Python, in the interactive Python, it's just going to print out that exact same list down here. Python, again, in certain ways is space sensitive, certain ways not space sensitive. The lists, doesn't matter what spaces come between things, it's always going to work the exact same way, and it'll always print it out the exact same way down here. The sort of standard variable name, there's a lot of sort of standard names for variables that programmers use in different situations, but the standard variable name that I'll be using for lists in this class is XS. So XS equals 1, 2, 3, like that. Created this list 1, 2, 3, put it in this variable XS right here. And now if I type XS down here, it just gives me this variable like that. The reason I use XS is that I use the variable X for like just numbers, things that have no like inherent semantic meaning to them. Just anytime I want to store something, then I'll just create a variable X stored in that. And then a list is like many things. So I make my variables plural anytime I have a list. I end it in S. So I might pronounce it XS, or in my head, I actually pronounce it like pluralizing the X. There's a lot of X's right here. There's 3 of them, so it's plural, should be plural. That's not required by Python. It's just something that I'll be doing in all the quizzes, any code that I give you, that if you see something that ends in an S, you know that it must be a list. If you see something plural, you know that it must be a list. So there we go, XS. One of the confusing things about the notation in Python with lists in these square brackets is that square brackets don't always mean that you're creating a list. Sometimes they mean that you're accessing a certain element in the list. So if I do XS square bracket 0 like this, if I have something to the left of the square brackets, the thing to the left of the square brackets, in this case is a list. It's always going to be some sort of container to the left of a square bracket. And then what's inside the square bracket is called the index into the container. So if I have a list, square bracket like this, then it's going to give me what variable exists at this particular index, XS at position 0. We often pronounce these square brackets as at. So it's saying this would be like XS 0 can be pronounced as XS at position 0, or just XS at 0. Or sometimes it's also okay to say just like XS square bracket 0. All those things are things that you'll hear me use just interchangeably as I'm pronouncing the code down here. Very, very common source of confusion and source of mistakes is that in Python, we start counting at 0. 0 is the first number for computer scientists, not 1. You were taught wrong your whole life. 0 is in fact the first number. And so when I'd had this list 1, 2, 3 up here, XS at position 0 gave me this 1 right here. XS at position 1 like this gives me 2, because 2 is the second thing in the list and 1 is the second number. If I do something like XS at 3, there's 3 things in this list, but there is no third element. There's a 0th element, a 1th element, and a 2th element, but there's no third element, something like that. You're going to get this an index error. Anytime you see something that looks like an index error, it means that you are whatever you've put inside the square brackets is either too big or too small for your particular list. Sometimes we don't want to just start indexing from like the left to the right. We want to go from the right to the left. And in that case, we can use negative numbers. There's a thing that was sort of invented by Python, and then everybody realized in all the other programming languages it was a great idea. So most programming languages do this now. But 20 years ago or so, Python invented this of putting a negative number to index from the right. And since there is no negative zero, like negative zero is just zero, so excess at negative zero is equal to excess at zero. Because zero is negative zero. I'm going to type XS here again so we can remind ourselves what this list looks like. XS 1, 2, 3 right here. And then if I do XS square bracket -1 like this, that'll give me that 3 position over here. So it doesn't go like left off the edge. You start counting. This is the -1 position. That's the -2 position. That's the -3 position. -1, -2, -3 like that. Pause here for questions in a second, but I want to jump back over to the cheat sheet and highlight where this information appears on the cheat sheet. So in this blue box right here, there's the front page. It's labeled sequence containers indexing. In this little dotted line box over here in the top left, it has this example list. This right here is not a 1. This is not first. This is LST list. Another thing that programmers in general hate is vowels, because who likes vowels? We just like consonants. So it's very common. You'll see in the textbook, any other resources with Python, if people are typing out the word list, they will just take out the I and type LST. So this is LST, not 1ST. And anytime you see LST, then you should think list. Here, so this is the contents of their list: 10, 20, 30, 40, 50. The top over here is the indexes, positive index, so 0 corresponds to 10, 1 to 20, -4, the negative index. So starting from the left, from the right going left, go -1, 2, 3, -4 would get me the 20 right here. And so this is the thing to reference. Make sure you understand this so that when you see an arbitrary list with arbitrary indexes, you know how to access it, what goes with what. And the main tricky thing to remember is that starting from the left, positive numbers, you start with 0 on the left, but starting from the right with the negative numbers, you start with -1 on the right. Any questions so far? Yes. Okay. Any other questions? Okay, go ahead. So the question is related to these slicing things down here. Haven't talked about slices. We've talked about just indexing. Indexing gets us a single element at a time. Let's talk about these slices down here. Slices get us not just one element at a time, but many elements at a time. So let's see, I'm gonna do LST down here and we'll just recreate that list that they have above, 30, 40, 50. So the list from the cheat sheet. And so if I do LST of 0, it's another way to pronounce these square brackets is as of. So LST at 0, LST of 0, LST square bracket 0, all those mean the same thing. Indexing at position 0 gives me this 10 right here. Indexing at position 1 -1 gives me this 50 over here on the right. Anytime you see the square brackets with just a number inside of it, means that the result is always going to be just another individual number. The slices gives you what's called a sublist. Slices give a sublist of the original list. So sub meaning like smaller, and then it still comes out as a list. If I have LST of 0:3 like this, it means that we're starting at this position right here, start at the 0, and then a colon going up to position 3. These work like ranges. So if we had the range of 0, 3 like this gives us the number starting at 0, going up to, and not including 3. Again, when you had the range like this, it doesn't display things. There was this built-in list function that we could use that would convert our range into a list and give us the actual numbers. We now know that this output down here is a list because it has these square brackets around it. And so this range goes, the range is analogous to the slices in that you start at the very first thing and you go up to the second thing, but you don't include it. So LST slice 0 to 3 gives me 0, 1, 2, but not 3 right here. These slices, just like with the range, you can specify like how many steps, what you want your step size to be. So if I have 2 colons like this, then it's just like the range syntax, that the first one is where you start, the second one is you go up to, but not including that one, and then the third one is how many, what your step size is, how often are you taking things. So when I do range of 0, 3, 2 like that, then this is the result, 0, 2. So these are the indexes that I'm using into the LST list right here. This is the LST list. So 10, 20, 30, 40, 50. These are the 2 indexes, position 0, position 2. So I get 10 and 30 like that. So yeah, good thing to remember. Actually, so personally, I never remember specifically about how the slicing works on lists. I always have to think, okay, how would it work on the range? Maybe even look up what is happening on the range if it's something complicated, and then in my head go back to, okay, now those are the indices into the list. So knowing that these 2 things work the same way. So then the question was specifically about how do these negative numbers work with slices. So let's, I'm gonna just sort of clear the screen a little bit here. LST, here's my list right like that. And let's say maybe I want to get just these 2 values over here. How might I do something like that? I know that they're at the end on the right-hand side, so I could use the negative indexing. I could use the positive indexing, doing something like, let's see, something that we haven't seen yet is if I have a colon without something on the right, it means go all the way to the end. If I have nothing on the left, it means go starting all the way from the beginning. So colon 3 like that will give me everything up to, not including position 3. 3 colon means that I will start at position 3 and go all the way to the end. So 40, 50 gives me this. The other index that I can use to reference 40 right here instead of 3 is -2. So if I try -2 colon, I'll get that same result because the -2 and the 3 happen to both correspond to the same position in this list, the 40 right here. And so when I go starting at position -2, go to the end like that, it takes me to the end. Common mistake or confusion here is that the thing on the left here always has to be your starting index. And so let's say I want to go from 20 to 40 using negative indexes. So 20 is going to be the -4 index. I'll verify that by doing LST of -4 like that. That gives me 20. And if I do colon, I want to go up to including 40. So I want to go up to the 50 position. -1 like that gives me 20, 30, 40, 20, 30, 40. This was the -4 position right here. This is the -1 position. Do all 3 of those things up to, but not including the -1 position. Starting at -4, go up to, not including -1. Yeah, the best way to get a sense of how these slicing things work and how these, especially all these negative indexes work, is just to work a bunch of problems in the with Python Tutor in the example problems that I gave you. So we'll go over and do that next. But before we do that, any questions about anything so far?
Replacing items in the list. How would you go about that?
Question is replacing items in the list. It's a great question. And we're going to talk in detail about this. Probably won't get to it today, but on Wednesday, about how the question is like, how do you modify lists or containers in general? How do you modify containers? And there's a lot of intro Python material that talks about this, talks about how to modify containers. In this class, you will never modify a container. If you ever feel tempted to modify a container somehow, then something has gone wrong. And there's lots of reasons for that. We'll talk about that on Wednesday. Today, the focus of this class is just going to be on like understanding the access to containers.
We won't be using, like, for example, append or any of those commands in this class.
We'll talk about it Wednesday. Yeah. Good question. Any other questions so far? Okay, maybe one last thing for us to talk about on this cheat sheet over here is so switching back to the second page, there's these generic operations on containers. The first 3 lines here, the length, the min, and actually the first 2 lines, sorry, not including sorted, but length, min, max, sum, those 4 functions are things that you'll have to know for the quiz. So let's go over and talk about those. The length, I think, relatively intuitive, tells you the total number of elements in your list. So here there are 5 elements. So the length of the list is 5. The maximum does what you might guess, give you the maximum of those elements. The min gives you the minimum of those elements, and the sum will add them all together. So those functions important to know for the quiz because yeah, they'll be on the quiz. The other things we'll talk about later in class. Those are the ones that you need to know right now. And then back over here, this operations on lists, this black box right here, this is the set of things that for modifying lists. And so that's the stuff that we'll talk about on Wednesday. And we probably won't get to dictionaries today either. That'll be Wednesday. So this box down here, we'll talk about on Wednesday. So important things for the quiz, what we're talking about right now, these first 2 lines under generic operations on containers on the back page, and then everything in this sequence containers indexing on the front page.
Right.
Yes.
Do those with the sum and the max command, do those break if there's like, let's say there's multiple variable types between the same?
Yeah, this is a great question. So the question is, Python is has what are called heterogeneous lists. Python has heterogeneous lists. So heterogeneous, just a fancy term meaning like different kinds of things. And so in Python, we can have like numbers like 1, 2, 3, and then we can also have strings A, B, C in the same list, and that works 100% okay. Other programming languages, if you've seen other programming languages like C, C++, Java before, do not allow this. They have homogeneous lists where everything must be the same. In Python, we have these heterogeneous lists. Things are allowed to be the same. We basically never want them to be different like this. So every example that we'll do in class, every assignment that you have will assume that the lists all have the same sort of thing inside of them. Either all have numbers or all have letters, or it's always the same thing inside. But you're allowed to do this. If we were to do something like this, and let's maybe first I'll highlight that. So you don't have to create a variable of a list to do something like take the sum of it. You can just create the list directly inside like this, and it all works fine. If I were to add something of a different type like that, you see you get this type error because sum is internally adding all these things together with a plus sign, and it says you can't add an int in a string. Doesn't make sense to do that. Somewhat related, let's say we take the sum of one thing, totally good. Sum of 0 things, that's equal to 0. That totally makes sense. If we take the maximum of one thing, that's just that thing. If we take the maximum of nothing, we get this value error because we don't know, like, you can't return 0 like you could with the sum, because what if the biggest thing was like negative? So the max and the min functions only work for non-empty lists. Sum and length work for all lists, whether they're empty or not empty. There's great questions thinking about like the edge cases. One of the good habits to be into as a hacker, as a programmer, is to be like thinking about how can I break my code? How can I break what's going on here? What are the things that I can do to lists that will cause these functions to not work correctly? And you want to be thinking about that, not so that you can break other people's code, but so that you know that your own code won't break. One of the reasons why we'll want to ensure that the contents of our lists always have the same type inside of them, or like always numbers, is so that we can do things like summing them or taking the max of them. So that's great sort of question, great way to be thinking. Jackson.
Say you have this big list of numbers, maybe from 0 to 9, but you only want to find the maximum or the subset of those numbers. How would you do that?
So the question is, we have a big set of numbers like up to 1 million, and how do we do things like on that? Let's first ask ourselves, like, how can we create a list of numbers up to 1 million? Well, one thing that I might want to do is like, okay, I'm gonna just start typing numbers up to 1 million, and we'll get there eventually, but we're not going to be happy about it. So we've seen before that we can use the range and the list to create numbers together. So just so that it prints out without taking up my entire pages and pages of screen here, I'll do up to 1,000. And recall that if I do just the range like this, then it's going to output like that. If I listify it, then it'll print out actually all those numbers like that. And so this is a really easy way to sort of construct lists about that have the contents that you want inside of them. And then let's say maybe I didn't actually want all the numbers up to 1,000. I only wanted like the even numbers. So I can do the (2) like that. And now I get all the even numbers. Or a different way that I could do that, here's my list up to 1,000. Maybe I already have that for some reason. Well, I could do slices somehow to get all the numbers up to all the even numbers up to 1,000. So slices, we saw before that if we did something like with a single colon like this, it's going to give me all those numbers back. So that's the same as like 0 to 1,001, going up to not including the very last number. But then if you have this colon over here, you can do a step size. Let's go up by increments of 2. So that gives me all of the even numbers. And here it's kind of annoying that I have to write like the start and the ending things over here. So you can just leave those out, colon 2, and that'll give you the same results. And anytime you don't have a number inserted in one of these spots related to slices, it's going to use whatever is sort of like the most sensible thing to use for that particular position. The most sensible thing to use at the very beginning is the beginning of the list. The most sensible thing to use about where you're stopping is the very end of the list. And the most sensible thing to use about like your step size would be 1. So that is equivalent to that, which is just equivalent to that. And so the question was specifically, how do I take the max of some like weird subset formula of weird lists? Then you could create it however you want and then just apply the max to it. And here we get, in this case, 999, because we went up to, not including 1,000. So yeah, when, on your lab this week, you'll be having to think about constructing things in all of those different ways. But again, for the quiz, we're breaking it down to just reading code to help you understand what you can even do with things. And So that's what we'll go to next. All great questions. Gonna jump over here, go over to Python Tutor. Go ahead and bring that up. And as we do that, I'm gonna, on my screen over here, I'm also going to bring up our the practice quiz handout so that we can see what those things look like. And I'm going to just copy this first problem into Python Tutor. So we're working on problem 1 right now from the practice quiz. And again, the practice quiz, or the quiz practice, as I wrote it, is something that you can have available for you during the quiz. So great. I left lots of white space on here so that you can take lots of notes about how things work on different problems. And I encourage you to do so. So jumping back over to Python Tutor, I'm going to type in the quiz problem, and I encourage you all to double check me that I am in fact typing it in correctly and not making a mistake. So there's problem 1 from the quiz practice. Did I get that correct? Did I have a mistake? Forgot a 21 at the end up here? Yeah. Thank you. Anything else I'm missing? So let's double check the indices, 0, 1, -3, 0, 1, -3, got those right. We got 1 to 21, 1 to 21, that looks good, okay. Now we're gonna visualize this execution. And the important thing for us at this point will be to see how does Python visualize, or how does Python Tutor visualize these container objects, these lists. So I'm going to press next here, executing this line 1. I know I'm executing line 1 here because the red arrow is on line 1. Press next. And you can see over here in this global frame, we have this XS variable created. And previously, all the XS variables that we've had have been what have been called primitive types in Python. A primitive type is something that is not an object. It's something that's like a number or just a letter that sits inside the actual frame over here. The container type is what Python technically calls an object. And so it has this little arrow from this position over here to the object way out over here. In this case, the object happens to be a list. And again, in this class, you don't have to ever memorize any vocabulary. You don't have to, I'm never going to quiz you what is the difference between a primitive type and an object. I'm just bringing up all of these vocabulary terms, again, in the spirit of immersion into a programming language. Just because when you see other people writing tutorials or in the book or videos that you're watching, people are going to be using these terms, and you just have to be comfortable enough with them to know, okay, I might not know what that is, but at least I have a rough idea, or I can figure it out, look it up if I need to. So again, these numbers here, primitive types, the list is the first of these objects that we are considering. The way this list is being displayed in this yellow thing that sort of scrolls off the edge of my screen over here is that these dark numbers that sort of are in the middle of the yellow boxes, these are the values of the list. Anything that we type inside the square brackets, we call those the values of the list. And then up here at the top, it's helpfully providing all of the indexes into the list for us. So we don't have to like walk through and count and say, oh, what is the index? What is the thing I put inside the square brackets in order to access this particular value right here? I know that it's the 5th one, or as Muggles would say, it's the 6th one. It's in position 5. And so it makes it easier as you're walking through this code, trying to predict what's going on. You don't have to like count ever. You just look at the top. This is the index, and this is the value down here. We'll see that how that appears here again in a second. I'm going to press next on this line 2, execute line 2, creates this total for us. Again, the 0 right here, a primitive type, not an object because it doesn't have this arrow. It just directly stores the value inside the variable, inside this global frame right here. So the total starts off as being equal to 0. And then the purpose of these first few quiz problems is just to get you practice, making sure that you understand how to do this indexing, how to figure out what is the correct value that corresponds to XS, in this case, XS at position 0. So XS at position 0, find the 0 in this list. The 0 is right here. 0 index corresponds to value of 1. So this XS at 0, XS square bracket 0, or XS of 0, again, all those equivalent terms, I'm going to replace that with a value of 1 right here. This is evaluated to a value of 1, and then add 1 to total, because that's what the plus equals does. So executing line 3 by pressing this next, and we can see that we did in fact add 1 to total right here. Now we do XS at position 1. Position 1 right here is this one. And so the value is 3. And so this XS at 1 will get evaluated to 3. We'll add 3 to total. So 3 plus 1 is 4. Press next. And we get 4 right there. Now the hardest one, the -3 right here, that does not display, Python Tutor does not display the negative indexes for us. It only displays the positive indexes. So when you see the negative index, -3 like this, you have to actually count from the right. And remember that the rightmost one is position -1. The leftmost one is position 0, so this is position -1, position -2, position -3. So my hypothesis, what I think is going to happen, you should always be thinking about what is going to happen before you execute it. What I'm thinking is going to happen is that XS at position of -3 is going to be equal to 17. And so when this is going to be evaluated to 17, we'll add 17 to total. 17 to plus 4 is 21. And so now when I press next, we'll see that 21 is in fact the result. And so my hypothesis was correct. It means I probably have a good understanding of what's going on. If your hypotheses are incorrect, you should go back and evaluate, figure out why it was incorrect. But then run this, we get the total equals 21. And so that's what you write down for the quiz answer. Again, the main purpose of this first question is to make sure that you have good understanding of how these indexing works and how to read and interpret this information on the right-hand side of Python Tutor over here. Any questions? Yeah.
Just to clarify, like with the negative, so you would, so one way to look at it is just do positive list and then go down.
Yeah, so the question is like about thinking about like what's the way to interpret this -3, and the suggestion was you think about it like counting from the right, going -1, -2, -3, and that's exactly how I think about it. That I just start from the right. This is the -1 position. This is the -2 position. This is the -3 position, and so this is my value of XS at -3. On your actual quiz that'll happen for this material, the particular list that you will get is going to be exactly the same list, and so you can feel free to just like have these indexes pre-written out for you with the positive ones and the negative ones, so that you can be 100% sure that you're never going to like make a stupid counting mistake. You can just look in your notes and say, oh, I know that this is position -3, or sorry, this one's -3 because I already have it written out. Great question. Any other questions so far? Okay. Another sort of meta aside is I realize in lectures I talk very fast about a lot of things, and that's again intentional for a number of reasons. One is that like with this foreign language learning analogy, native speakers talk fast. You need to get the experience of listening to native speakers talk about things. And the other is that just like the reason I talk fast is so that I can say the same thing in like 20 different ways. And so if one of the ways that I said just doesn't like click with you, that's totally okay, as long as you feel like something that I said about how to work with these negative indexes clicks with you, makes sense for you, then that's okay. You don't have to understand 100% of everything. You just have to understand how you can go about doing this thing, whatever makes sense for you. Okay, so I'm going to switch back over to the problem set down here. There's a handful of different variations on this first problem with just different values for these indexes so that you have different things to try to practice with. Problem 4 gets us into doing something slightly different. It has this slice going on. So again, my lists that I create, I use sort of generic names in these quizzes, especially because there's no semantic meaning for any of these variables. When you see XS, you just think like it's a bunch of blahs, it's a bunch of random things. Similarly, YS, it's just a bunch of things. We don't know what it is. Total has a meaningful name because it has a semantics to it. I'm doing some like addition to it, adding things together. So total variable actually stores a total inside of it. But the X's and the Y's, they're just like things that I don't care what they are, they're just things. So we're going problem 4 now, typing it into Python Tutor, edit this code. So we had XS and then we had YS equals XS slice 3:5, I believe it was. And then down here, YS 0, 1, -1. 0, 1, -1 like this. Visualize this execution and we'll see what's going on. The main thing about this problem, again, is the fact that line 2 right here has been added. So the main thing this is testing is your understanding of slices, that if you don't figure out what this slice is referring to correctly, then you can't do the rest of this, the rest of this problem at all. And so I'll press next right here, create this XS variable, which points to this list object way over here. And now I'm going to execute line 2 right here. Run that. And we can see that it creates this other variable, this YS, and it creates this new object over here with totally different indexes and totally different values. In this case, these indexes and values are computed from the XS list according to this formula right here. We start at position 3, we go up to but not including position number 5. So looking over here, this is the XS at position number 3 contains a 7. We go 3 and 4 up to but not including 5. So 3 is 7, 4 is 9, and then we stop. And so down here we have the 7 and the 9. The 7 and the 9, those correspond to this 7 and 9 right here, because that's what the those are the indexes that I happen to select, 3 to 5. But now notice that the indexes up here in the YS list are different than the indexes into the XS list up here. That if I was to wanted the 7 out of the XS list, I need to look at position number 3. But if I want the 7 out of the YS list, I need to look at position number 0. And down here, when I'm computing these totals, it's very important to notice that all of these totals are related to the YS list. I'm doing indexing into the YS list and not into the XS list. And so when on line 4 right here, when I run this line 4, it's going to look at YS at position 0. So YS at position 0 will give me a 7, which is different than XS at position 0, which would give me a 1. So we'll get this 7 because we're looking in the YS list, and we'll add 7 to total when I press next right here. Get total is equal to 7. Similarly, when I do YS at position 1 like that, looked at this 9 right here. So 7 plus 9 was 16. There we go. And now when I do YS at position -1, starting from the right, going left, this is position -1 right here, will be a 9. 9 plus 16, 25. And then print out the total equals 25. So the key thing to make sure for this type of problem is that you get this like index, this slice totally correct, because if you get this wrong, then you can't get anything else right. And that's a very true sentiment for basically everything in this class, but especially the quizzes. If you make a mistake on like line 2, figuring out what line 2 is supposed to do, then there's just no way that you can get the other answers right at all. So you have to make sure that you get each of these lines correct before going on. Yes?
Would you say that the learning curve class is more steep and flatten out, or is it more just kind of learning?
Yeah, the question is like, how does the learning curve for this class, what does it look like? And I'd say for the vast majority of students, the next 3 weeks of this class is by far the hardest part of the class. Because there's just so many like subtle technical things about like if you miss this one concept right here on this line, then you can't get anything else of this problem. and the hardest part of this class is just like getting that sort of that laser focus in on technical things, focus on just one line at a time, make sure that you can figure out what it's doing, and then move on to the next. Once you have that skill down, then the rest of the class is, I won't say like trivial, but it's definitely way, way easier in comparison. So most of the hard stuff in this class is like this part at the beginning. And generally the students who say like week 10, week 14 in this class, having the most struggles are the students who did not fully master the material at like this portion of the class. So yeah, huge cliff in difficulty right now. Like if you feel like you're climbing a mountain, climbing a cliff, that's because you are. But then it will level off and become a gentle walk after this. Yes.
I understand why in the YS list 7 is the first one, the third value in the list. Sorry for the YS list, but I don't understand how 9.
Sure. So the question is, why is this the YS list down here? And I'll walk through exactly what's going on. So here on line 2, this is the line that defines the YS list. Another time, anytime you see an equal sign, that is also a definition of the thing on the left-hand side. So line 2 here is the definition of the YS list. And YS is defined to be XS, starting at position 3, going up to, but not including position 5. So we start at position 3 right here. And then a good way to think about these slices is, again, to think about the ranges. So if I'm going to go back over to VS Code right here, and our slice looks something like 3 to 5, like that. And so I want to think about what are the ranges that correspond to starting at 3 going to 5. Again, I can type range 3, 5 like this. It's not going to show me the actual numbers. But if I make that into a list by applying this list function around range like this, then it's going to show me the actual numbers that correspond to starting at 3 going up to, not including 5. So in this case, 3 and 4. In order to get the actual values that correspond to this slice, I get the values that correspond to these indexes right here in the list that I'm looking at. So we have the value at index 3 and the value at index 4. Come back over to Python Tutor, the value at index 3 is 7, the value at index 4 is 9, and so that's why down here we get the 7 and the 9. So again, lots of different ways of thinking about viewing each one of these problems, each one of these concepts. Once you find one that works for you, it's totally okay just to stick with that. You don't have to, yeah, as long as you can evaluate one of these lines, then you're good. Great question. Any other questions so far? Okay, so let's come back over to the notes. And so the next few problems, dealing more with slices like this, and in particular doing really weird things with slices, like with negative numbers. And so again, the right way to think about these, the way that I think about them, is think about it as ranges. Always go back to the idea of a range, starting at this position, going to that position. Now, problem 6 and 7 and beyond start using these functions like length and sum. And so let's take a look at these. Yeah, let's take a look at 6, and I'll do some variations on 6. So starting at edit this code, I believe it was -5 up to -3 like that. And then let's see, total equals length of YS like that. So press next. So we get that same XS list as before. Now, if we think about this, we start at position -5, go up to not including -3. So -1, -2, -3, -4, -5, that'll be this position right here. And then this was 3, so we'll get both of these two positions, the 6 and the 7, so we'll get the 13 and the 15. Press next. There we go, 13 and the 15. And now we want to calculate the length of that list, ys. Press next, and we get 2. So the main reason for introducing this problem right here is so that I can do something like this. And 100% guarantee this will appear on the next quiz. If I do these indexes in the wrong order, I go like -3 to -5. At first, this looks like something that should like work, should give me something reasonable, like good as a result, because -3 seems like it's smaller than -5, because 3 is smaller than 5. So it seems like this thing is actually on the left of -5, but it's actually not on the left of -5. -3 is on the right of -5. And so if I start on position -3, this is position -1, position -2, position -3. Start at here, go up to, but not including position -5, which is right here. This is -3, this is -5. Starting here, going up to, not including this one right here. Well, I'm adding 1 each time, so there's nothing for me to do because I'm already past the final location. And so if I press next, we'll see that ys gives me an empty list, that there's nothing in this list from -3 to -5. The original list that I wrote was -5 to -3. -5 is smaller than -3, so when it comes to the left, it's going to actually be to the left over here, and there will be values inside the list. But when you have something larger to the left of the colon than the thing to the right of the colon, then you're going to get an empty list. And this doesn't at first look larger, but because it's negative, -3 is in fact larger than -5. So the thing on the left of the colon is larger than the thing on the right of the colon. So we do get a negative list. And so the length is going to be 0 in this case. So guarantee somehow on the quiz, there'll be a situation like this where there's a slice and the thing to the left of the colon will be greater than the thing to the right of the colon. Any questions about? Yes. And this would be true for positive numbers as well. So if we did this from 5 to 3, visualize that execution, go through, we get an empty list right here because the thing on the left is greater than the thing on the right. And again, coming back over here to our ranges, if we do range from 3 to 5, make that in a list. So this is exactly what I have above, 3, 4. But if I do range 5, 3, the thing on the left is bigger than the thing on the right, so there's nothing for us to get inside the range. If I do -5 to -3, the thing on the left is smaller, so there is stuff for us to do. But if I do -3 up to -5, then we get an empty list because the thing on the left is bigger. Most students, after thinking about it for a little while, it makes sense why this happens, but it's really, really easy to lose points just by forgetting with negative numbers that -3 is in fact bigger than -5. So make sure that that you pay attention to the negative numbers. Yes.
I have 2 questions. One is the reason why it's not giving us an unvalued object rather than just a variable. And then 2, on the quiz, would you either write list range, 3 to 5, 3, 5, or would you write it the other syntax as both?
So the question is, on the quiz, will these happen in range or in slices? And it could happen either in a range or in a slice. So you have to be able to understand either way for both the range function and the slices, how it works. And the other question is, Python has this special thing called none, which hasn't come up yet in this class. Why is, if there's nothing in this list, why is it not giving us this none type? And the videos have talked about, the pre-lecture videos have talked about this none type. But the reason is that this is not nothing that we're getting back. An empty list is not nothing. It is a list that contains nothing, a list with nothing inside of it. So we'll be talking about none here later in the next couple of classes, but just know that we're getting an empty list as the result when there's nothing back inside of our slice or our range. Great questions. Any other questions so far? Okay. Gonna come over to scrolling down. There's some for loops down here. Problem 15. So your coming up quiz, the quiz on Wednesday, goes over for loops and goes over ranges. And so the quiz that will be the following week will also have for loops inside of it. And so if you can't do the material on this quiz that we're having next class session, all that material is going to appear somehow again on subsequent quizzes. So all the studying that you do for our class on Wednesday is like it's also studying for all the subsequent classes in all the subsequent quizzes in this class. So you really want to make sure that you understand these for loops, not just for this coming quiz, but for all the other quizzes. Let's come back over to VS Code and I'll type out this problem 15, total equals 0 for I in range 3, I believe. Total plus equals excess at position I. That's the correct problem 15. See some head nods. Okay. Visualize that execution. And now the thing, so there's nothing new about this material that's going on here. It's all stuff that's been covered so far somehow. It's just combining things together. So again, on this for loop, so this will be a little bit of review for our quiz on Wednesday. When you have a for loop, the I right here is going to go over all of these values that get returned by the range. So it starts with 0. So I is equal to 0. And now when we have a formula like this, we'll substitute in the I value, in this case 0 right here, and we get excess at position 0. Excess at position 0 gives me a 1. And so we added 1 to total. The next value of I is going to increment up by 1. So now it's at 1. And then we'll do excess at position 1. At position 1 gives me a 3. So substitute in 3 right here. Total plus equals 3 gives me 4. Total is 4. So next iteration of the for loop. So we have I equals 1 right now. So then after 1 will come 2. Total plus equals excess at position 2. Substituting the 2 in here for I right there, excess at position 2. Excess at position 2 right here gives me a 5. So we'll substitute in a 5 right here for excess at I and do total plus equals 5. 5 plus 4 will give me a 9. And there we go. Now we go up to not including the number inside the range right here. So up to not including 3. So we hit 2. 2 is the last number that we'll consider. So we're not going inside the body of this for loop anymore. We're going to jump down and go down to the print statement right there and print out that total equals 9. So all these like list indexing, you have to be prepared to see those inside of for loops, inside of if statements, inside of functions, and so on. Any questions about this problem? So it turns out that this pattern is super common in Python, where you have in all programming languages, where you have this like a loop over somehow the indexes into a list, and you want to access all of the values in that list. I could do length of excess like this. And if I do that, I'll just walk through this here in a second. This now is going to, all the I values are going to be all the particular indexes into this list. And excess of I right here is going to be all the particular values inside of this list. Very, very common pattern having something like this. And so in Python, we have what's called syntactic sugar, which makes things a little bit easier for us to do, because sugar makes food better, syntactic sugar makes programming better. And so for x in xs like this, total plus equals x. These two lines of code, so again, the hashtag right here is a comment, means that this line's not going to be executed. And these two lines up here, what I had before, 100% equivalent to these two lines down here. When I have for variable in list, this variable x is going to take on all the values of that list, ignoring the ignoring the actual indexes. So down here, for x in XS, press next. X gives me a 1. Notice that it doesn't start at 0. It's not giving me this index here. It's giving me this value right here. Add 1 to total. Now the next went from 1 to 3. X went from 1 to 3 because it gives me the next value right here. And then 5, and then 7. I'm looking at all the x's. We're seeing that it goes through all the values right here. Then 9, then 11. So the key thing here is that this pattern right here, exactly the same as this pattern right here. And this pattern is actually far more common in the Python world, whereas this pattern might be more common in other programming languages. Looking at the indexes, totally ignoring the indexes and only looking at the values is more common in Python. For your actual quiz, once we get into these like for loops, I'm not asking you to do an entire large list like this, because that's a lot of busy work and hackers hate busy work. And so if we come down to problem 18 right here, problem 18 is exactly what I have typed into Python Tutor right now, except I've just shortened the list so that it stops, goes 1, 3, 5, and doesn't have all the other numbers inside of it, because I think this, if you can do it for those 3, then you can do it for all the other ones, and just don't want to have to do the busy work. So if we delete these, just make this list smaller like that, visualize the execution, step through that, just jump to the end, last like that, total equals 9 is the answer for problem 18. And the key thing here is just this new syntax of looping over the values of the for loop like this, instead of looping over the indexes of the for loop. Are there any questions about this syntax? Yes. Could I summarize the difference again? Oh, so the question is here, couldn't I, instead of doing this for loop right here, couldn't I use the sum command? And the answer is yes, that I could say total equals sum of XS, something like this, and it does the same thing. This, in fact, is how the sum function is implemented in Python. It's just a for loop that goes over each entry, adding up the total, and then returning the results. Was that the question that you were asking? Great questions. Any other questions? Okay, this is all the material then for the quiz. There's some more problems that combine those things together that definitely recommend you look at. But Wednesday in class, we'll talk more about this idea of modifying lists, talk about these dictionaries, and we'll have your quiz. So please come prepared for that. And if anybody has questions, I will stick around and answer them. But otherwise, that's it for class for today.